Hello, this is section 6.8, which is about complex numbers. In complex number, we're going to talk about, let's say, okay, square root of negative 4. So, so far we have said that the square root of any negative number is undefined, right? So in this section, what we're going to do is we're going to introduce a number called imaginary number. So where the square root of a negative number, or in this case, square root of negative 1 is I. So this is a fact where I is an imaginary number. All right, so this is a fact, formula, whatever you want to say. All right, so square root of negative 1 is I. Square root of negative 2 is not I. Just square root of negative 1 is I. All right, so then if you know this, then now we can find the value of square root of negative 4. So square root of negative 4, we can also say negative 1 times 4, right? Because negative 1 times 4 is still negative 4. Now, after this, we can split this into two terms like this, right? And now we have square root of negative 1. Square root of negative 1 is I. So I times square root of 4. All right, so square root of negative 4 is I times square root of positive 4. All right, and also from here, since we have square root of negative 1 is equals to I, and if we take square on both sides, then since the root is 2, so we can get rid of this. So on left hand side, just have 1, and right hand side we have I square. So basically I square is equals to negative 1. This is also another fact or formula. All right, so basically here we are going to use these two things. Okay, so now first let's or instead of plus, let's just say minus. Okay, so here now we are subtracting these two because we have minus here, right? So we don't need this parenthesis. So here we can just distribute this negative to these two terms. So first, negative times negative 3 is positive 3. Negative times positive I is negative I. And just like we did when there was a x, it's the same thing. We can just treat this I as an x, but the only thing, or the only new thing we introduce here is, well, are these two, right? So that's the only new thing here. Now we can just subtract or just combine these two. First, combine 14 and 3, which is 14 plus 3 is 17. And another one, negative 6, negative I is negative 7I, right? Okay, and the next one, let's say we multiply these two. So we are multiplying. There's a multiplication sign here. So when you're multiplying, again, we need to multiply everything, right? If you're multiplying, just multiply everything. So first we can multiply just numbers. Negative 2 times 5 is negative 10. I times I is I squared, right? Because I times I is, well, this one has the same base with 1 on the power, so 1 plus 1 is 2, so I squared. And I square, we said right here, I square is a negative 1, right? So here we can say negative 1. All right, since we're multiplying these two, so there's a multiplication here. So now negative 10 times negative 1 is positive 10. All right, so yeah, you just have to use this formula here, or this fact here. All right, now the next one. Rationalize this. So rationalize, we have done this, and I don't remember, maybe 6.5 or 6.6 with the square root. So when we're rationalizing this thing, so basically the idea here is to get rid of I from denominator. So to get rid of I from denominator is to multiply numerator and denominator by the conjugate of, in this case, the denominator is 4 plus 3i, so the conjugate of 4 plus 3i is 4 minus 3i. All right, so if there is a plus here, there is a minus here. If there is a minus here, there is going to be plus here. All right, so that's how we find the conjugate. So now multiply numerator by the conjugate and also the denominator by conjugate. So this way, now we can get rid of the I from the denominator. So now just multiply the top, 3 plus 5i times 4 minus 3i over, and the denominator 4 plus 3i times 4 minus 3i. All right, so on the top we are multiplying these two, so let's just look at the top or numerator part first. So on the top we need to distribute this 3 to these two terms, right? So distribute 3 to 4 and negative 3, and also distribute this positive 5i to, again, these two, 4 minus 3i, right? So this way we get 3 times 4 is 12, 3 times negative 3i is negative 9i, plus 5i plus 4 is 20i, and positive 5i, negative 3i is, well, first we can just multiply numbers. So 5 times negative 3 is negative 15. I times I is I square, right? So now, as we said before, I square means negative 1, right? So we can use same fact here. So here we can replace this I square by negative 1, right? So this way, well, first let's do this. So 12 and negative 9i plus 20y is plus 11i. And since we have a negative here, so negative, since we're multiplying these two, so the negative 1, negative is a positive 15. So 25 plus 12 is 27 plus 11i, right? That's what we get from the top, and for the bottom, we have this 4 plus 3i times 4 minus 3i. So this is again similar to a plus b times a minus b. So a plus b times a minus b is, do you guys remember this? This is a square minus b square, right? This is a formula. So so when you compare these two, a is 4 b is 3i, right? So now using this fact for denominator, we can say a square and b square. So for the bottom, a square 4 square minus b square is the whole thing 3i, and take the square of this whole thing, not just I, whole thing, both 3 and I. All right, so this way we get 16 minus 3 square is 9 I square, and again I square is a negative 1, right? Just like I said here. So 16 negative 1 times negative is a positive, so positive 9, which is 25. All right, so now we got this from the top, we got this from the bottom, so let's just combine this. So for this, for the top we get, so our final answer is, for the top we get 27 plus 11i over, for the bottom we get 25. So after this, well, it's okay to leave your answer just like this, or you can do one extra step. Just split this into two terms. 27 over 25 plus 11i over 25. So you're just splitting this 25 to both terms. All right, so this is called rationalization. So this way we don't have any I in the denominator. So that's what we're trying to do. All right, so yeah, that's it for this one, this section. Thank you.